Atoms are very small, but there are two ways we can get enormous amounts of energy out of them. These are nuclear fission and nuclear fusion. Nuclear fission powers electricity generators. Okay, but nuclear fusion powers the sun. Fusion wins. But first, we'll look at nuclear fission. This means splitting atomic nuclei into smaller pieces. But not just any old atom will do. We need big ones. Uranium and plutonium are the business. Either of these can be used as fuel in nuclear reactors. In fact, particular isotopes of these elements work best. They are uranium-235 and plutonium-239. They both have large nuclei that split easily when we hit them with neutrons. Let's have a look at chain reactions. First, we need some nuclear fuel. We'll use this uranium. To start things off, you fire some neutrons into your lump of uranium. When a neutron hits a uranium nucleus, it splits into two pieces. This releases a lot of energy. And it also frees 2 or 3 more neutrons in the process that zoom off at high speed. If they hit other uranium nuclei, they'll split them too, and so on. Each split sets off more and more reactions. This is called a chain reaction. Things could get a little out of hand, as you can imagine. Nuclear power stations use chain reactions just like this. Yeah, that is a bit scary. Of course, the rate of the reaction is carefully monitored and controlled with control rods that absorb some of the neutrons. This means the chain reaction goes along at a steady pace, otherwise the whole thing could snowball and it'd be curtains. Now, for something completely different, nuclear fusion, the other type of nuclear reaction. Here's the sun. It's really hot apparently. The enormous amount of energy the sun produces is created by nuclear fusion. Fusion is the opposite of fission. Fusion is about joining atomic nuclei together, not splitting them apart. Here we've got 2 hydrogen isotopes. Hydrogen 1 is just the usual type of hydrogen. But notice the surprise appearance of a neutron in hydrogen 2. In a fusion reaction, these hydrogen nuclei join to form helium nucleus. In fact, it's a helium-3 nucleus, not the usual isotopes of helium-4, which has 2 neutrons. In symbols, we write it like this. We include the mass number and the atomic number for each atom, so we can see exactly what is going on. The mass number is the total mass of the nucleus. That's protons plus neutrons. The atomic number is just the number of protons. Fusion reactions release enormous amounts of energy, much more than feeble old nuclear reactors and nuclear bombs. So it'd be a great source of energy for us humans. But no one has found a cheap, practical way to get fusion working yet, which is a shame. Nature can manage it though. All the stars, including the sun, are massive balls of fusion reactions. They release enormous amounts of energy, including light and heat, that reaches us here on Earth. Free energy! Great! But is this sustainable? Well, no, but don't worry. The sun won't be running out of hydrogen for quite a while. That's going to take a few more billion years. So don't change your holiday plans just yet.